proportion. A proportion is an equation that states that two ratios are equivalent. Okay, proportion is an equation that states that two ratios are equivalent. Okay, basically, a proportion is comparing two ratios. Okay, not necessarily two rates. A rate's not going to be, you're not going to compare two rates in a proportion sense. You may compare them, but you're not going to put it into an equation and try to solve it. What we're going to be dealing with today is strictly just proportion, just ratios that are equal to each other, that are equivalent to each other, but they may be missing a part. For example, if I had 5, 6, and that's equal to x over 18. So obviously, if 5, 6 of the people in here got an A, and there's 18 people in here, how many people got A's is what they're trying to figure out. Okay, or if 5 out of every 6 people go to Starbucks in the morning before they come to school, and there's 18 people, how many people went to Starbucks? Okay, that's what they're basically asking here. Okay, now, there is several different ways to solve proportions. We're going to learn 2 of them today. Okay, we'll learn the third method on Thursday when we go over section 3. But first way is this, is we look at these two ratios as just regular fractions. Okay, in other words, what did I do to 6 to make it 18? Multiplied it by 3. Okay, and so I do the same thing to the top, because to have equivalent fractions, whatever you do to the bottom of one fraction or the top of one fraction, you must do to the other fraction. So if we multiplied 6 times 3 to get 18 on the bottom, then we got to do the same thing at the top. 5 times 3 is 15. So x would be equal to 15, and that's your answer. Now, real honestly, the proportions you're going to be dealing with today are fairly simplistic. Okay, we'll get into some of the harder ones on Thursday when we cover section 3 and we start talking about the third way to solve a proportion. Okay, the other way to solve a proportion, now, let me show you an example. I'm looking for a specific example. And they don't give you any of those. Okay, we'll get some of those on Thursday, I guess. All right, let's look at another example. B over 14 is equal to 27 over 42. Okay, now we have to look the opposite way. What did I divide by 42 to get 14? 3. And so we have to divide, you divided by 3 here, so we have to divide by 3 here. 3 goes into 27 how many times? 9 times. So that means B has to be equal to 9. In other words, we had the equivalent fraction like this. Let me redo it this way. And we reduced it down to where there is 14 on the bottom here. So we divided by 3 to the top and bottom. That makes that 9. So that is B equal 9. Okay, so if you're going from the larger fraction back to the smaller fraction, then obviously you have to divide. If you're going from the smaller fraction, the smaller numbers on the fraction, to the larger numbers on the fraction, then you're obviously multiplying. So you have to look at, did I increase the number or did I decrease the number where I'm looking for it? Okay. Now, they're not going to give you any of these today, But you will have proportions that look like this. Okay, where the letter or the variable is on the bottom of one of the ratios. You will have them like that. Like I said, there's not any specific ones today, simply because of the two ways that they're teaching you how to solve these. One of the ways won't work if it's down there on the bottom. Okay, and so, or it will, it's just a little bit more complicated. Okay, so all the ones you're going to deal with today are going to have the variable in one of the numerators of the ratios. Okay, the top number of the ratios. Now, but to solve this, you simply do the same thing, okay, that we did on the last problem. What did you have to do to 75 to take it back to 3? We divided by 25. So we said 75 divided by 25, and that's equal to the 3. So then I have to do the same to the bottom. 100 divided by 25 would mean what? 4. So A here would be equal to 4. Okay, and the common thing that we did to the ratios is we divided by 25. Okay, so like I said, you won't have any with the variables on bottom today. We will on Thursday. Well, you know, because you obviously have to be able to solve it regardless of which one is missing. But we'll talk about another way to solve those particular types of problems and all proportion problems again on Thursday. Now, let's look at the other way to solve. The other way to solve these proportion is this way. And this is one of the required ways to do it, so please write it down, because you go, well, it's easier just to do it the other way. Well, yeah, it is, but sometimes life is not easy. You got to do it the hard way. Okay? Now, the other way to solve a proportion, so the way we just did it was with the equivalent ratio method. This is the algebraic method. Okay? And it goes in line with what we sort of talked about in previous chapters. Okay? This is just an equation that we need to solve. When we solve an equation, we're trying to do what? When you solve an equation, what are you trying to do? Trying to figure out what, Nicole? The letter. We're trying to isolate or solve the value of what the variable is. Okay? So we're trying to get the variable by itself. Well, here, there's the variable. I need to get it by itself. So, once again, we're dividing 8 into x and say that we come up with 35/56. Okay? Well, the inverse of dividing 8 would be to do what? Multiply by 8. So I'm going to multiply by 8 over 1 to both sides. Over here, it cancels, leaving me with x. On the right side, I can go 8 into 8 once, 8 into 56 7 times. And so that's 35 over 7. Now, let me make sure which form they want your answer in. Okay, yeah, you're going to have to, you can't leave it as an improper fraction. This is an easy one. Okay, you can't, sometimes, eventually in the future, when you're in algebra classes like Algebra 2, Geometry, they'll allow you sometimes to leave it in improper fraction form. Wanted to make sure that was not the case here. It's not the case here because it will reduce into a whole number, which is 5. Because 7 goes into 35 5 times. Okay? So always reduce it. Most of the ones, I believe all the ones you're going to have today are all going to be whole number answers. Okay? Eventually we'll have some that are not. They're fractional answers. And especially when you're dealing with proportions, you have to leave them in those fractional answers. Okay? So, 35 over 7. Let's look at this one here. A over 32 equals 9 over 16. Okay, it tells us to solve it using the algebraic method. So that means we have to solve the equation. We have to isolate, in this case, A. We have to get A on one side of the equation or the other. Okay, to do that, then we must multiply both sides by 32 over 1. Okay, 16 into 16 goes one time. 16 into 32 goes two times. These 32s cancel over here on the left side, leaving me with A is equal to 9 times 2 on top, 1 times 1 on bottom. So A would be equal to what? 18. Okay, A is equal to 18. Haley?
How do we know when to do algebra?
Because the directions tell you to. Okay? All right. If you haven't got your books open, make sure you've got them open, and let's look at number 26. Now, we're going to do quite a bit of word problems in this section and in the next few sections, because a lot of times proportions they're used a lot in word problems. Okay, setting up two ratios, seeing which one's missing. We've already really sort of done that with the rates that we did the other day, when they had, for example, they had 350 miles in 1 minute, and then it was equal to blank in 1 hour. Okay, and so it's just that's sort of what these proportions are. Okay, number 26 says you're driving 2,760 miles across the country. During the first 3 days of your trip, you drive 1,380 miles. If you continue to drive at this same rate each day, how many days will the entire trip take? So, we want to set up two ratios. Okay, why? Well, because that's the section we're in. Okay, we're going to set up a proportion that is made up of two ratios. Okay, the first ratio would be what? To what? Okay, but I got to have a ratio, so I got to have a fraction. So what is the ratio? That is part of one of the ratios, but it's not the ratio. What is the ratio? No. Think about our rates and ratios, what we've talked about in 6.1. Okay? We talked about having a certain amount over 4 pounds, and we wanted to find out how much a pound was, right? Okay? So you want to look at, it's a ratio in the sense of it's a fraction, okay? But realistically, this problem, the ratio is really more of a rate, and it says that. It says if you keep this same rate, when are you going to finish this trip? Okay, how long is the trip going to take you? Okay, so really we're going to do a rate. All right, so as we look at this problem, there are three things. Okay, let's talk about the three things. What is the very first thing they give us? What first number? 2,060? Okay. So the total miles is equal to 2,760. Now, what's the next number they gave us? 380? 3 days, okay. So next one is 3 days. That's how long we've traveled. I'm getting there. What's the next number they gave us?
1,380.
So 1,380 miles is equal to how far we went in 3 days. So, which one's going to be related? Okay. How about we look at this? 3 days, 3 days. So which numbers are going to be related? 1,380 over 3 days. Now, this is miles, and this is days. So our other ratio has to be the same thing, miles over days. So the miles were 2,760. We don't know the days. Okay? Now, you could reverse these two ratios. In other words, you could do this. This would be the same thing. Okay? You could do exactly the same thing. Either way is fine. Okay? The whole thing is this. We're looking for this. So this is on the large fraction. So we ask ourselves then, what did we do to 1380 to make it 2,760? By 2. We multiplied by 2. So we must do the same thing to the bottom number. Okay, so we must do the same thing here. And that gives you x is equal to what? X is equal to 6. And so it takes 6 days for the rest of the trip. X equals 6 is what the proportion equals. Then you tell the answer 6 days. Okay? All right, I want you to try number 25 on your own. Okay, do 25. I'm going to give you 2 minutes to do it. 25. Who's got an answer for 25? Gracie. 15. Yes, 15 erasures. That is correct. Okay? Let's make sure, let's read it real quick and make sure everybody understands how we got that. It says school supplies. At a store, 5 erasers cost $2.50. How many erasers can you buy for $7.50? 2 ratios. Okay? First one is the first amount that they gave you, $2.50 over 5, and that's equal to how much they want to spend, $7.50 over the number of erasers. Okay, I keep putting it on bottom. Like I said, it does not matter. You still solve it the same way, as long as you're not solving it algebraically. Okay, that's the way algebraically you can do it, but it's a little bit more complicated. But this is easy. Okay, what did I do to 250 to make it 750? Times 3. Okay, so we multiplied by 3. So we do the same thing at the bottom. Okay, 5 times 3 is your 15. That's where you get your 15 erasers. Okay. All right, so some of those are very similar to the ones we're doing there. Now let's look over at page 279 at number 31. Okay, it says on 31, salt water. It says the salinity of salt water, of salt water is the ratio of the mass of the salt in the water to the mass of the salt and fresh water mixed together. Okay, now it tells you what you've got to have. Right there in the problem it says the salinity of salt water is the ratio, okay, so there's your key word, ratio of the mass of salt in the water to the mass of the salt and fresh water mixed. Okay? So on top you have the mass of the salt. On the bottom you have the two that are put together, the water and the salt. Okay? So that's what they want you to, that's your ratio. Now let's read the rest of the problem. 31A, a sample of salt water is made by mixing 3 grams of salt with 75 grams of water. Find the salinity of the sample. Okay? So the sample of salt water is made by mixing 3 grams of salt. So what is the mass of salt in the water? 3 grams. So I put, this is A, so I put 3 grams. Now, here's the part where some people make a mistake sometimes. Okay? Now, if we move on, it says, with 75 grams of water, find the salinity of the sample. So, 75 grams of water. So what goes on the bottom of my ratio? No.
Oh, question mark.
What? No. Sure we do. This is not a proportion problem. Okay, what is the bottom number supposed to be? The mass of salt plus the fresh water. The mass of salt plus and the fresh water. So, yeah, there's 3 there, 75 there. So that's 78. Now I reduce it. Okay, we can reduce it by 3. 3 goes into 3 one time, 3 goes into 78, 26 times. So, 1/26 is the salinity of that particular salt mix. Okay? Now, a sample of salt water has a salinity of 3/45. So that's a ratio, right? So that tells me the ratio for B is 3/45. Okay? All right, so that means that there is 3 grams of salt, and so how much fresh water is there? If there's 3 grams of salt, how much fresh water is there? And I don't even know what they want for the rest of the problem. I just want you to understand what their ratio is. Sorry to keep you up. What? What would how much fresh water is there if there's 3 grams of salt? How much fresh water was mixed? What? Who said 52? 15, no. No, look, folks. We just had right here. No. This number right here represents 3 plus some number that will equal 45. Because there's 3 grams of salt, so there has to be 42 grams of fresh water. Now, like I said, I don't know what they're asking. I just want you to understand what they're saying. They're saying in this particular canister of water, the salinity is 3/45. Okay? That means I got 3 grams of salt in there, and I've got 42 ounces of fresh water. All right? Now, the rest of the problem states the sample has a mass of 30 kilograms. How much salt is in the sample? Okay, now, they've changed it. Okay? They said the sample has a mass of 30 kilograms. Okay, so now they want us to use that ratio. Now we're looking at the proportion. 3/45, that's equal to the mass of this water, which is 30. Okay, and they want to know how much salt it has in it then. Okay, so they said the ratio or the salinity is 3/45. So if we just take that specific one and say, okay, what's the amount of water and what's the amount of, okay, then you do what we did. But they're saying that this is the ratio and it matched that 30 grams of water. Okay, the mass is 30 grams. So I have to figure out then, what did I do here to get back to there? Huh? I divided 15. Okay. This one you're going to have to solve algebraically. Okay. Why? Why is that? Well, what do I do to 30 to make it 45? I don't know. I do. Obviously, y'all don't, but I do. I know what you did. Okay? So we've got to solve it algebraically. So to solve it algebraically, we've got to take and multiply both sides by 30 over 1. Okay? This cancels. Make it 30 over 1. Okay? And so that gives me, I can cancel here. Okay? 15 goes into that twice. 15 goes into that how many times? 3 times. Correct? Okay. So that gives me 2 times 3 on top. 1 times 3 on bottom. That's 6 over 3, which is equal to 2. So there's 2 grams of salt. Okay, so on 31, 32, 33, 34, you've got to look at, you're probably going to have to do a proportion. Okay, so your homework is this. And the word problems are worth double X's. So if you go home and say, well, I'm not just going to do the word problems, then you're going to get double X's off each one. And if there's 2 parts to it, then that means there's 4 X's. Okay, so we're going to do 9 through 28. This is 6.2, 9 through 28, and 31 through 34. All right, still got about 9 minutes left, so go ahead and get started.